wanted to take an opportunity to speak with you guys about something very special that is going to be coming up. Some of you may have heard about this before. Some of you heard about it very, very recently. It's called Hack in the Box. Has anybody gone last year? Don't think so. So Hack in the Box is a security conference that occurs in Amsterdam, Netherlands. Information had gone out about this earlier in the year, and people had said to try to get everything done. The deadlines have already come and gone, but it is being extended. So if somebody is interested in Hack in the Box, there still is an opportunity to take part and participate in it. This is an industry conference. It's a non-academic conference. It's a hacking conference that occurs in Amsterdam, Netherlands. So there's some different major security conferences, of which this is one of them, have different areas of focus. DEF CON is much more hacking oriented on the hacker side. Others are more just cybersecurity oriented. It could be more for some business professionals, cybersecurity professionals. Hack in the Box really does embrace the hacker aspect of it. So that's something to be aware of and to consider. So if you're interested in some of the latest and greatest that may be going on in terms of hacking and exploitation, then this is an opportunity to do so, and to do so in Amsterdam, Netherlands, of all places. It's been around for about 10 years. So they have things to go on in Asia, I think usually Singapore, as well as Amsterdam. Amsterdam is a great place to visit. Obviously many canals, very open-minded Dutch people that reside there. Very different attitudes than you might find in the U.S. So in Amsterdam, you'll find that drugs are legal. You'll find that prostitution is legal. There can be things such as, the red light district, where you can go there and you can see a female prostitute that will be there, and she'll have her wares on display, lit by the red light. And you can go and look, but if you want to make use of the services, there is a cost, obviously. Of course, if you're in a security conference, but looking for a security clearance, they both start with a C, then you obviously want to avoid that kind of behavior, because it's going to be problematic. That reflects poor judgment. But it is there. Some people, you could walk around and you could see it. It's not going to put you in danger, but obviously you want to exercise sound judgment and not make use of it. It's an opportunity to get involved in the hacker conference. You're part of the crew, so you help out. Maybe you're into blue team and stuff, and you might help out with the blue team village, or maybe many different possibilities. That also enables you to get some extra special perks, like there's a speaker party. You get invited to the speaker party. Can have an opportunity to meet and network with some more people that way. So the cost for that is $3,000 with flight. So if you're a local student or even just close by, that would go out of probably Minneapolis, and transportation would be provided to there. $2,000 without the flight. So you'd be responsible for finding the flight on your own. And this is open to anybody, graduate student, undergraduate, online student. I believe even alumni are able to participate in it. So part of it is you help out. They do also, if you go and check out the Hack in the Box website, which I have it open somewhere, but you can go there, check it out, and you'll see that it costs over $1,000 for a regular person to attend. Another potential possibility is to go as a student. There is a student rate that is, I think, $90. And I haven't asked Dr. Stroshan about this, so I mentioned it, the possibility to him. So if you really wanted to go, but you're like, I don't want to help out, I want to spend 100% of my time doing other stuff, then you probably could do that, but you would have to pay an extra $100 or whatever. And you'd also lose out on some of the stuff, like there's some, the speaker-only party, and I believe it gives free food to the people who are helping out with the conference. I'm not sure if that's available if you're not. So that is a great opportunity to meet people, to network, to have a really good experience. There's a lot of other, talking about some of the semi stuff that would be legal in the U.S., but it's legal there. But there's other very good, legitimate cultural things you can do there, like Van Gogh. You can go. There's the Reich Museum, or I don't speak Dutch, so it's probably mispronouncing it, but a very famous, well-known museum. They have canals, and you'll have an opportunity to ride on the canals. It's a very wonderful experience. Everybody bikes. You can rent a bike if you want to. It's maybe semi kind of dangerous because you're kind of riding along a canal and you can maybe fall in, and a lot of them do take the biking pretty seriously. So if you are interested, it is coming up in April. I've actually applied to speak there. I've applied late, so I don't know. I'll find out maybe in 2-3 weeks, hopefully, if I'm a speaker or not. If I am a speaker, then I'll be there. If I'm not, then I probably won't be there. So if you are interested, what you want to do is you want to contact Dr. Stroshan or contact Alex Woolman and let them know that you're interested. And we can set that up, and you would need a $500 deposit pretty soon. And then the rest of the money would be something that you would need to negotiate with Dr. Stroshan. If you know for sure, this is something I want to do, I absolutely want to go to Amsterdam, and you can come up with a $500 deposit, then talk to him. He'll probably be able to work something out with you. He'll let you know what's possible, but you'll need to come up with a deposit probably pretty soon. I know for some people payday is the end of the month, so it's possible they might even accept that, and you don't know until you ask. But he's asked to try and see if we can get more people that are involved in this. So if this is something you think you might want to do, then it's something to consider. There will be a group of DSU students, probably 8 to 16 of them. So great opportunity there. And I'm trying to think of, don't forget some things that... Oh, very important. So if you say, I want to go, I'm going to pay the $500, I'm going to do the deposit for this, and then you decide, I've changed my mind, I'm not going to do it, you're already locked in. So you pay the $500, and even if you can't come up with it, it'll eventually come out of your student account. So only pay the $500 deposit if you know for sure that you're going to do that. And of course, online students, then it's open. We have a lot of online students. Many of the online students have seen a DEF CON, they've seen a Black Hat, or they've seen other local conferences. But, so the end of the middle, in part of April, so it's a few months. There is travel insurance too, so if you get sick or injured, and that'll cover you or take care of it. If you have some kind of family catastrophe, or you have overcome by sickness and you can't go, then that travel insurance could take care of you medically, or it might even be able to reimburse your cost of going there if you have a documented medical reasons for not being able to participate. So with that, we'll get into our next part of the class. And what I wanted to do is start by trying to talk some about, so we're going to be kind of, to some extent, a little non-technical. We will be getting more increasingly technical and working heavily with debuggers, IDAPRO, Ghidra, so on and so forth. But I also want to make sure I give adequate attention to the idea of vulnerabilities and vulnerability discovery. So if I give you a lab and I say you're looking for this type of vulnerability and it's a simple lab, then that's something that's kind of, to some extent, it's kind of artificial and contrived because it's just too simple, it's too easy. Some of them can just be harder to find the actual vulnerabilities, and I'm going to try to make the labs so that they're not too simple. So you do need to think a little bit about the vulnerabilities, and so we'll spend a couple days or a few days, or we'll see exactly, talking about some of the nature of vulnerabilities, what they are, and finding them, and giving some actual examples, working through the vulnerability discovery process. Because we can break some of this down into different stages where we're looking for the initial vulnerability. This is our entry point, our way into the exploit. And then we take that, and then once we find the vulnerability, then we engage in exploit development. We weaponize that. We take it so that we can actually do something powerful and malicious. So as we start out, I think it's a good place just to start with the introduction into vulnerabilities and some of the techniques and thought processes that go behind that. I also have some examples that we'll walk through where we'll just kind of spend some time just walking through it in detail and trying to work through the vulnerability discovery. And so at the heart of this comes down to the idea of software security. So software security is something that we would violate when we engage in software exploitation. The absence of software security is something that we need to move forward with exploitation. And we can have a number of different people that will look at software security and assess it for different purposes. Maybe you're somebody who is trying to make your own software more secure. So a lot of this material could be applicable to somebody who they're talking about today. It could be for a defender and trying to make things more secure. You could also take the approach of I'm a hacker and I'm looking for the vulnerability and I want to develop it and I'm going to access it, and so I'm concerned with software security for a different purpose altogether. We ultimately want to undermine that software security. If software security is too strong, then it may be too difficult to do software exploitation. Or as we get more low level into it, we can see that we may have partial way into it. We may have some vulnerable functions. Maybe we even have a buffer overflow. But there could be some other mitigations, countermeasures that are in place that make it so that we can't advance beyond that. So software vulnerability is what we look for as a way to reach that exploit. So we want to consider the nature of what a vulnerability is, the nature of what a software bug is. And so I probably should have bugs at the top because it's maybe it makes a little bit more sense. A bug and a vulnerability are not necessarily the same thing. We can have bugs that are not useful, bugs that are benign, or I shouldn't say benign, but they're just not security relevant. They're just, you're a programmer, you're a developer, and you just have some errors and mistakes. Maybe the user interface is screwy or it does some weird stuff. And it's just not security relevant. Other times it can result in unintended, strange, aberrant behavior. Some of those will rise to the level of vulnerability, some of them may not at all. For software exploitation, we are interested in bugs that potentially could be security vulnerabilities. And what these are the unintended flaws or oversights that can potentially allow software to be compromised. Is doing something erratic. Ideally, a lot of bugs, when you're dealing with compiled software, is you are looking for things that will result in a crash. A crash is very good. If I can take this bug that I discover, maybe this bug that leads to a buffer overflow, then that's a crash. I could potentially weaponize that. Maybe there are mitigations like DEP or ASLR, which if you don't know what that is, that's fine. We'll discover those later on. But with their bypasses for those, we can do those. But if you think about it, I say a buffer overflow. What is a buffer overflow? And there are many different things in your code that could lead to a buffer overflow. And so we will explore some of that, and that's just one category of memory corruption as well. So, and just an aside here, if it sounds like we're starting kind of basic and non-technical, to some extent we are, but I want to try to provide a good foundation and provide some of the background knowledge so that when we talk about vulnerability discovery, then you actually, if you want to, you can do some of that more on your own outside of something that's just a very simple contrived toy binary, which we'll use some toy binaries, but hopefully I hope that they will encompass enough of this that you do need to engage in some of this thoughtful process. So giving to provide a definition of exploitation is we have a vulnerability, we have some bug, and we are using it to perform unintended computation. Doesn't need to be malicious, could be benign, but it's not intended by the developer. They did not foresee it. And you could even go further, and some people say arbitrary computation. Sometimes with the extent of the computation that you may go to could be complete and total, where you have what's called Turing complete. You could do every conceivable instruction set would be possible. Some of them are going to be much more limited. We don't need things to be Turing complete where we can do where anything is potentially capable. Because if you're dealing with things at a low level, dealing with disassembly, using shellcode or return-oriented programming, which we'll get into much later on in the course, then those could potentially go in any direction. ROP or return-oriented programming is Turing complete. So does it need to be anything possible to be exploitation? No, it just needs to allow you to do some unintended computation. It's much more broad and open-ended there. We have the idea of implicit security policies. Security policies with respect to software is what is it that a piece of software should be able to do or can be able to do? What are reasonable expectations for a software? Should it be allowed to, if I'm using a piece of software, some kind of online database, should a user be able to go in there and change the price of something? That's an implicit security policy that is being violated because you would expect that they would not be able to do that. So that's going to be something that's the heart of exploitation. Sometimes there may be well-defined security policies. Others, it's not defined anywhere, but there's just a reasonable expectation that this should not be acceptable behavior for a software or maybe you're going beyond the software and you're doing something in the operating system. Maybe it escapes and it's dealing with something that you're turning it into a kernel exploit. Which I don't think we'll deal with those. We might talk about that, but another possibility for exploitation is it doesn't necessarily lead to something where you're going to go and do arbitrary computation. You're executing shellcode, you're making it do something. Maybe it's just information leakage. Maybe that's all you care about, and that can also be very devastating. The Heartbleed, has anybody heard about that? So that involves some information leakage, obviously. So if your goal is just to leak valuable information, it could be somebody's credit card numbers, or it could be even security specific things, like maybe it helps you to decrypt something, passwords. Very open-ended in terms of what it could be. Information leakage could also be low-level details. One of the things that John was looking at, and one of the things that he did is he was looking for ways to bypass ASLR. So he was looking for just certain things that could be leaked. So it could be something that maybe that you may use as part of what you're doing, but more likely than not, if it's low-level leakage, then you're already doing the other type of exploitation. So typically when you make use of exploitation, there's going to be some kind of exploit script that will be employed. So you might be Python script or Perl script. And this class will focus more on Python. That's what I'll recommend. If you want, it's open-ended. You can do whatever you want. If you want to do Perl, I don't think a lot of students in this idea locally on campus probably know it, because it's not, to my knowledge, taught here. Online students, I'm sure some of them probably know it. But we can use something like a Python script to do a number of different things. So vulnerabilities can be very, it could deal with file formats. So maybe it's a media file, maybe it's an MP3. We'll look at some of that and work through some of those in great detail, low-level detail, and how that could be used for vulnerability. I mean, it's possible that some of your labs may very likely deal with some of that. I could use the Python script and I could have it actually create a media file. I could find the hexadecimal, the headers and structures, replicate those, have correct values in there, replicate those, do all of that kind of stuff. So those are all possibilities. If you want to interact with something that is connected to the internet or connected to the network, then Python script is great for that. So you can connect to that, you can get feedback, you can use that feedback and draw upon that. Some of the Python scripts that are network based can be very complicated. There are many different steps that are going on. We'll learn how to do some of that, but at this point, the idea is, just be aware that we'll be dealing with exploit scripts. Security. When we want to consider the idea of what security is, we can look at it from this is semi-non-technical, but the triad of confidentiality, integrity, and availability. So if you were in an information assurance program, you'd probably learn quite a bit about some of those. We'll just kind of mention this somewhat briefly, but won't really touch on it too much. But if we talk about these big, grand ideas, we should have a complete, comprehensive understanding of what they are, what they entail. So confidentiality, that means that there's some aspect of it that should remain hidden. It should be safeguarded. If we can violate that, then we're violating security. Integrity means that we can trust that the data is sound, that it's accurate, that it's correct. If I have John that's going in there and he's changing things and violating integrity and and then somebody else is not aware of that, then the integrity has been violated. We've violated the security. People have reasonable expectations that the integrity in certain things will be as it should be. Availability, and this can vary to some extent, but if something is online, then we expect that it's going to be available 24/7 all the time. If it's something like a piece of local software, and it's not a business software that I'm using, then we may not have that expectation of availability. On the other hand, maybe it is something that is business related, and I have an enterprise contract, and I do expect that it is going to be up and running without problems. If it's down for whatever reason, then that's going to be a serious problem. We can attack availability as an attacker, so we could do a DOS attack, a denial of service. Sometimes those are easier to do. Sometimes denial of service is all that you can do. You can't go any further. But it is still an attack, and it still can be a valuable attack. If you can take down somebody's business and it's costing them money, they can't do what they need to do, then those are things that are great to be aware of. Auditing software is something that we will take a look at. So in this course, we will be spending time dealing with binaries, but I also want to introduce the idea of a non-binary approach. So if I actually have the source code, how would I audit that? What does it mean to audit the software? Because if you think about it, that's what you're really doing when you're trying to deal with software exploitation. You have a binary, trying to attack it. You're stuck with a binary. Stuck looking at the disassembly in IDAPRO or Ghidra. If you have the source code, make use of it. Absolutely. VLC is an example, and we'll look at that much more closely. You can go and, even though it's compiled, you can go and download the source code because it's open source. So you could go and read through that and find some stuff inside there that you could attack. And we'll talk very in depth about that later on. So what exactly is auditing a software? It's engaging in rigorous analysis of it. It could be compiled binaries, or it could be actual source code. And for our security purposes, all we care about is trying to discover the vulnerabilities, specifically security vulnerabilities. We don't care about other bugs, just because they're not relevant to us. It's not our concern. Auditing is something that a lot of times is not done. I think people are getting more and more security-minded developers. Cybersecurity increases in importance, but it's still something that is neglected. Reasons for that is deadlines, a very competitive, cutthroat environment, rapid development of things, and so much people to get stuff out there quickly, and then they fix the problems later. I think a lot of the younger students are probably, some of them play video games, and some of them, or maybe this is not true in a graduate program, but it would be an undergraduate, I don't know. Some of those are put out, and then the bugs are created or captured, and not captured, but discovered and corrected, patched later on. Time is money. If you have to spend time trying to audit and remediate those vulnerabilities, then it costs you money. If you have to miss deadlines, that costs you money. Security skills deficits. A lot of those developers, their security knowledge is very limited. They went through a computer science program, not a cyber operations program. They don't know anything about any of that type of stuff. And some of the students in this course may not know anything about it, but you'll learn, because that's part of what this course is. So you'll learn some of the security skills that are relevant to auditing. So don't worry if you don't know. They may not understand the need for that software. Maybe they do understand, but they just don't care. So auditing can take on a number of different forms for us. So we can have in-house software audit that could be done pre-release. The actual security team itself is going to be trying to address those security issues and try to fix them, correct them. And it's ideal that you do that, but you also want to do more than that. If that's all you do, then if you really get down to it, that's probably not enough. But doing it beforehand is better. It's good to have security baked into your lifecycle development process, but that's another class, so we're not going to talk about some of those types of issues. In-house software audit after it's already been released. At this point, the bugs are out there, security issues, but if you can still find it and remediate them, then you can still avoid some security incidents. If you have a security incident and somebody compromises it, and then that's going to make you look bad. People may lose faith in you. You could lose money, or maybe it will have no effect because it'll be patched and people may not care. They're used to things. It really depends on what it is and the impact it has, the severity of it. I mentioned the idea that a lot of people don't have the training to do these audits very well. You may be a great programmer, but you're not trained in some of the security stuff. And so in that case, third-party audits can come into play. And that can come into play in a couple of different respects. So you could actually hire a company to go and do that. Like VDA Labs, Jira DeMott's company. That's a service that they could provide, where they go through and try to enumerate all these different vulnerabilities and discover them. Well, people very highly trained, and hopefully at the end of this class you'll learn some of the skills, some of the stuff to look for. It could also be independent security researchers. So somebody has got the training. They don't need the source code. They get the binary. They can do a very complete and thorough analysis on their own. And maybe they approach the organization and try to. Some of them can be more upfront about wanting something. Others may just give it to them and hope that there's a bug bounty in place. Or a bug bounty reward. So some companies will provide bug bounty rewards where if you notify them of a bug, they will give you financial rewards or some other kind of award. If some of them have the policy stated, other times it's not stated at all. Some companies, if it's not stated, they may be hostile, they may ignore you, they may try to play it off as irrelevant. You can also deal with vulnerability brokers, like Zero Day Initiative. We'll talk about those more at another time when we talk about bug hunting. But so third party, I guess bug hunters. I have these separate, but bug hunters could also just fall under to this as well. There's people that independently look for the security vulnerabilities and different possibilities in terms of how they could use it. If you are a bug hunter, you don't have to play nice. You can do whatever you want. You could make use of it yourself as a 0 day, an O day. For some of the online students who may not know, an O day is you have a brand new vulnerability that has never been discovered before. Nobody knows about it. If you don't know about it, it hasn't been patched. If it works, if you can get it to work and you develop it on your system to a full exploit, nobody else knows about it, then it's going to always work because it's not patched. So if you turn it in to somebody, or you share it with somebody and they turn it in, then it gets patched and it's no longer useful. So O days are very useful, very important with respect to the bug bounties. Another option is you could sell it on the underground. So malicious actors will pay for these. If you get in with the right people on the underground, dark web, then that is an option. So bug hunters don't have to play nice, but they still go through the same process. Whether you're a bug hunter, you're doing it in-house, then you still go through the same process of same tools and techniques, just different people, different ways of how they can deal with that. So that brings us to the idea of, we talked earlier about, you actually have the actual source code. You know, it's written in C or C++ or whatever the case may be. That's ideal. But if it's not, if it's a compiled binary, that doesn't mean that you're completely shut out either, because you can still attack it. You still have many opportunities to completely corrupt it, to discover vulnerabilities, and that's primarily what we'll be doing in this course. I do want to, spend a little bit of time talking about when you actually have the source code, but primarily it will be black box. So this means, it's compiled binary. We don't have the source code, but we are trying to attack it and discover what we can about it. First places we want to start are entry points, because you could have a vulnerable function that is inside something, but if we have no way to reach that, then that's not useful for us. We need to have a way to get there. An entry point is a way that we can get our input in there. It could be network based, it could be file format, maybe you go and play an MP3. And there could be a multitude of different entry points. Maybe your input is, say, an MP3, but there's more than one entry point for that. Maybe there's typing, maybe you're registering for a password or a username, and there's a buffer overflow there. Maybe the entry point is navigating the file structure. That's actual input, you're interacting with it. So any of those are potential areas. We want to identify those entry points and then see what happens. And one way to do that is to try to craft input to try to cause unintended behavior, things that should not happen. Ideally, having a crash. If you're looking for low-level exploitation, you're developing an exploit, that's probably, you're mainly looking for a crash. But sometimes, if you can get it to expose sensitive data, then maybe that's all you care about. That's something else that can be. But in this class, we'll primarily be looking for things that we can exploit at a low level. So if it does crash, then there's a good chance that we may be able to potentially use it as a vulnerability. It may lead to exploitation, it may not. So fuzzing. How many of you have heard of the idea of fuzzing? Okay, so this is the idea of we automate the black box testing. So you could do fuzzing manually, where you just go through that process of providing it with malicious input. Another option is to automate that, to have a tool that can cycle through and do it and provide input in a number of different ways, and then it goes through and tries many different cases. It collects the results, sees if there's a crash or sees if there's some kind of aberrant behavior, and then it can report on that to you. To some extent, you can be like throwing a lot of different data to software and hoping that something bad happens. If something bad does happen, it doesn't mean you understand it. You get a crash because you have, maybe you're sending some text and you sent 500 A's, just try to keep things very simple at this stage. Well, maybe it's a buffer overflow, but where in the software is the buffer overflow? Because you might have a buffer overflow on one situation, one set of circumstances, but you may need more going on. You may need to make use of certain features. It can be useful in giving you a starting point, but that starting point may be You need to go beyond that. So you need to discover more after that. And we'll explore that in great detail, how we can do that at a low level. If we do discover a vulnerability, there can be multiple code paths that lead to that. So I find a buffer overflow, and for some reason, this way that I caused the crash, maybe it doesn't work, but I go and I trace through it, I trace through the input, and I see there's another way that I can cause that. So tracing through all of the input will be very useful and relevant. Hopefully, if you find a crash, then you are able to go through and reverse it and figure out the vulnerability. Many times that is going to be key for exploitation, particularly if something is more complicated. On the other hand, sometimes you may not need to understand it to exploit it. If you can fuzz it and you get this behavior and you can understand the behavior that results, you may not necessarily need to understand the underlying behavior. On the other hand, if you want to move beyond that and you're like, I'm somebody who's developing these vulnerabilities, discovering the vulnerabilities because I want to make money doing this, I want to maybe make it a career out of it, then you do need to go further, because when you turn in these reports, some of what they look for is quality. How well can you explain it? Can you actually discover the vulnerability, or do you just have a couple screenshots? You've found a crash, but you don't understand it. And this comes from many different sources, but specifically, if you're dealing with compiled binaries, and you're dealing with a company like Google or Microsoft, these are things that they're going to ideally want. I mean, if you don't understand it, you still can get something out of it, but you're going to get more out of it if you understand the actual vulnerability. So we also, in this class, we want to consider, why are we engaging in the software exploitation? Are we just doing it because it's an academic exercise, or because we are trying to actually learn about it so we can make use of it at some point? So we do want to try to go further and to engage in the vulnerability discovery process. The fuzzing can be useful because sometimes it can very quickly discover a lot of vulnerabilities, and sometimes those vulnerabilities may not be found otherwise, because some code can be, particularly commercial code, can be very complex, very complicated, and developers have come and gone. There have been a number of different changes, and this is especially true for some like use after free bugs. Some of that can be very complicated. You create something, and then you free it in this one place, this one class in the code, and then somewhere else, completely else, is used again. But if you look at it in your developer, it's not really a straightforward, easy thing to determine, because it's a very huge monolithic piece of software, and it's not something that happens 10 lines later. It's an entirely different class. It's something that's not obvious. You'd have to go out of your way to maybe look for circulated vulnerabilities to discover that. And the use after free is a very useful software bug that we'll talk about later on. Classification of vulnerabilities. So we could classify vulnerabilities based on commonality. What is it that they do? And this is really just a convenience for human beings, so that we can, if we have a buffer overflow or memory corruption bug, that type of thing, or is it a use after free? What classification does the vulnerability belong to? Sometimes it could overlap and belong to more than one. So a taxonomy could be a means of classifying it, and there could be different ones that exist, formal or informal. We're not going to worry about that too much in this class, but as we learn about this, it's a good idea to understand that they exist. And we could also look at vulnerability classes based upon the software development lifecycle phases. Ones that are design vulnerabilities. These are ones that are flaws that are inherent in the architecture or the specifications. The specifications, when I set out to create a program, I create the specifications. I create the requirements saying what I want in the software. I create the specifications saying how I'm going to do that, and then I go and use these specifications to actually design and create it. But we're probably more concerned with our implementation vulnerabilities. These are actual low-level technical flaws in the software, mistakes that somebody made. They're not using functions correctly, or maybe they're doing a UAF or whatever the case may be. These are the vulnerabilities that we would exploit. Operational vulnerabilities are things that may result because of improper configuration in a certain environment, or it's not deployed correctly. So sometimes that can come into play into software exploitation, particularly if you're doing something more like a pen testing type situation. You'd be really more concerned with those types of things. For this class, we'll be more concerned probably with the first two, but more specifically with the implementation, the low-level details. So these are the design vulnerabilities. These are oversights that arise out of, initially when we're trying to envisage what goes on in the software, and we make some. We don't think about it as clearly as we should, and consequently, there are some inherent flaws that exist. As I mentioned, they are guided by the definition of the software requirements. You create a list of objectives saying that what we want our software to do, and then the specifications tell us how. So requirements are the what, and the specifications are the how. Implementation vulnerability. Here the code it's meeting the design requirements. We set out what we want it to do, but it's just the way in which it does it is problematic. There's some poor coding practices that lead to security vulnerabilities, and that's what this deals with specifically. It's possible that it may deviate from specifications. Specifications may exist, but they may change and they may not be updated. For our purposes, we don't really care what their specifications are, because we look at it at a different stage after it has already been created. It can also arise out of the programming language, C, C++, errors, mistakes, not using those correctly or properly. Finding these implementation vulnerabilities is going to be, when you do code auditing, that's going to be a central area of focus. Operational vulnerabilities, these may deal with the use of software in specific environments. How does it interact with it? It's not things that are inherently part of the code. Do we necessarily care whether it's concerned with design or implementation? Sometimes it can be a gray area where it can encompass both of those. And if we can find something at a low level that we can exploit, maybe it's because of poor programming choices, or maybe it's because somebody just thought through it very naively and their thinking was off. If we can exploit it, we don't really care. It's useful maybe to some extent when we engage in vulnerability discovery, but ultimately we just want to see if it's exploitable and if we can exploit it. Input is going to be something of tremendous interest to us. I mentioned previously the idea of entry points. We're concerned with entry points. The entry points are our gateway into the software, the program. So where to start? How can we get input into it? Can we somehow influence the software in some way, whether we're interacting with it? Maybe it's a piece of software that it's a server, it's online, there's some client that connects to it, the client sends commands, the commands are some kind of unknown hex code, and we observe it, we figure out what those commands are or what it does, and maybe we run Wireshark or something, and we see some of the traffic that goes over. We see some of the commands that go over the wire, and maybe we create something with Python to connect to that, and we can replicate it. And I mentioned hex, so it may not be simple text. It may be actual binary content that could be going over something that's not reproducible that you could type on a keyboard. But that doesn't matter. We could capture that hex and the Wireshark, and we could put that traffic, and we could send it over there over the wire and see what happens. So when we do discover a vulnerability, we need to be aware of a means of input. So what I just described there, that is one way of providing input. We're providing that input through sockets. We could provide it through a file format. It could be a binary file, it could be text, it could be any type of input that anything that we can influence. I'm trying to make that as broad and open as possible. So just because, again, there's a vulnerability, but if we have no way to reach it, then that's not useful. So we do a code audit, or maybe whether it's open source or binary, and we find some unsafe vulnerable function, which we'll talk about those more at a later time. But there's no way to reach it. So even though it's unsafe, it's not useful to us because we have no way to get to it. So input is important, and also tracing of input. Input could go many different directions once you get into a piece of software. There could be many different code paths. So we want to trace through some of that very carefully to see where it could get to. So buffer overflow vulnerability is an example. Very long command line interface input that could come on there. And can we somehow get that to reach an unsafe function that we can make use of? So understanding the input flow is going to be useful to us as well. Understanding the idea that the input can and often is transformed significantly. The path that it travels is one that is not simple. And we'll just show some different techniques about how we can trace the path, whether we do it through code audit or actual binaries. So buffer overflow, 500 characters past a particular point. That may work in certain circumstances, but there may also need to be a requirement that other special conditions need to be met. So maybe we're fuzzing or just playing around with something manually. And we get a buffer overflow to occur in one situation, but that's not always true. So I could have, say, I have an MP3 file in there, and there's some particular field inside the MP3 file. I'm speaking in terms of binary content, because we could have a header, and we could have other things inside there, and so some aspect of the actual inside the file, 500 characters exceeds the buffer. And there's some ways in which we interact with that in the software that may trigger an overflow, but in other cases it may not. The flow is important, because if that MP3, we need to have special circumstances for it to occur. Maybe we use some particular function. Maybe it's pausing or playing. How do we discover that? Is tracing. If we get a crash, then we know a crash occurs at this one point. We can use things in a debugger, like a WinDebug or Immunity or x64 debug. We can set breakpoints. We can figure some of that out. And there are commands inside of WinDebug. We can look at the stack, and we can trace what happened in the stack. So we can use our WinDebug to see what led up to that. We'll show you how to do some of that stuff later on. So potentially any data that goes into software can be exploitable. A lot of times it's not. A lot of times it's perfectly safe. VLC, for instance, maybe it's a specific file format that is vulnerable. Why is that particular software vulnerable? Because there might be different components of the software that deal with that particular file, and it's written in an unsafe way, but the other ones are written in a safe way. It just comes down ultimately to the vulnerable functions, the software vulnerabilities themselves. So if we just have a trivial, poor understanding, I did a buffer overflow of 500 and I got an overflow, that's kind of an inadequate understanding, because we need to discover the root cause of that. And we can find the root cause by digging in a little bit deeper. Input validation is something that is often present in software. So this idea of taking input and transforming it into a state so that it's safe. So input validation is something that happens, often. Input could be validated, and it still may be useful because it may overlook some things. Input validation is something that a human being initiates, a programmer initiates. If they can't conceive of something, if they don't do it adequately, then it still could be potentially vulnerable. Or they just may not bother with it at all. Maybe they don't care, they don't know about that. Tracing is something that it can be tough work, it can be time-consuming work. But if you go in there and you find something that looks like it's, maybe you're doing a source code audit and you find something that you know is a vulnerable function, you know that it can lead to a buffer overflow, or you see a use after free, you want to trace through it, and it's a huge complex piece of software. It could take a fair bit of time. Sometimes if it's not, it may not take a fair bit of time. And, it does vary. At the low level, we could also just make use of breakpoints in our debugger. So we could figure out what happens from point A to B, and rather than, if you wanted to fully trace everything and look at if you're dealing with the source code, look at every function and every direction that a particular variable goes or pointer goes to, or whatever the case may be. And doing that in IDA Pro, of course, or Ghidra would be much more challenging. If we can use breakpoints, that sometimes can simplify our work, but if we simplify it, there is also the possibility we could miss out on some things too. So it's good to be aware of that. Sometimes if you are thorough, you can catch things that would be missed otherwise. So data flow, so the code path of execution. You look at software in a binary, looking at the disassembly in IDA Pro, and you see all these different directions where it could go. It's obviously can be very non-linear in terms of where the data flows. This is particularly true if the program is very large. So programmers often, they don't think too well about I was trying to think about a homework and whether I should pause and I'm going to pause for a second here. Well, I do have a homework assignment that I have the homework, but I don't think I brought it with me. So I have a homework assignment that it'll be on the video at the end of the video. And a lot of what I do is I do on a different computer, and I just bring the stuff with me. And so if I forget to bring it with me, then yeah, I forgot it. So we'll talk about that on the video, at the end of the video. So I apologize for that. So the programmers, they may not always consider everything that goes on with input. They may think of things that are very obvious. Well, what about stuff that's non-obvious? If you're looking for somebody's name and I put down 5,000 characters, are they going to think about that? Or if I'm trying to order, negative 20 bags of cat litter, that's probably something that some people may not consider, but a hacker or an attacker would. They consider every possibility. And that's what you do with fuzzing, whether it's a manual process, an automated process. You know, an input may be something that maybe you get in it, the input is an MP3, and it's not going to trigger an overflow immediately, but later on, depending on which functions inside the software are called upon, if it's this vulnerable function, then in that place, then the input could come into play. And so you could have your input specifically crafted so that it can exploit that. How can we overcome EIP? How can we then lead to our shellcode and execute that? Those are things that we'll be looking at in low-level detail. So I hope people are not concerned because we're talking about non-low-level details here. A lot of times programmers think that things will be correct, they'll be well-formed, and it may not be. And they may consider other possibilities, but they don't consider enough of them. So they may have some partial input validation. It goes all back to the idea of tracing input. And this is speaking broadly in terms of vulnerability development, vulnerability discovery. You know, you're trying to find and discover your own 0-day or O-day. So you'll need to spend time tracing input. If you don't engage in the tracing of input, then you're probably not going to get very far. Now that said, you know, not everybody is going to be looking to be engaging in vulnerability discovery and development. Interfaces are going to be gateways into the software. So maybe you're making some aspect of it available through a network interface, and the programmer may not consider that the attacker can be aware of that, they can find that, and they're going to be excited by that because they can deal with that. You know, they can create a Python script that can work with that. Maybe you even have your own custom protocol, and you think, oh, I made my own protocol and I have my own encryption scheme. It's safe, but it's not, because attackers enjoy those kind of challenges, and they can everything you do they can figure out, and they can discover the encryption schemes and decrypt it. If it's there in the actual binary, or if it's something that is available that can be found, if it's in the standards document, then you could go out there and find it and make use of it. You know, the problem is sometimes programmers blindly accept that the input will be well formed, but that's not always going to be the case. Hey everybody, it's Dr. Brizendine. I wanted to add to our video, since I clearly did not have this assignment sheet in class, just a simple, simplistic warm-up exercise to get us to start thinking about C and C++. We will primarily be dealing with compiled binaries, but they will be written in the languages of C and C++. So how this works is we have some server code provided to you, and you want to get this so that it accepts from the user or the client standard in. So however you want to do that is fine. It's just some form of accepting standard in, and then we put that in a loop. So that means we get some input from the client. Say I type my name Bramwell. That's my name if you don't know it. And then the server will then print that. That's one thing the server does. And then the next thing it sends it back to the client. So it'll print it again. And then at that time, the client has opportunity to provide other input, hence being a loop. And that will continue on until it gives a special string to terminate. And that string is quit. So if it sounds kind of easy, it kind of is, but it'll make us need to think a little bit more. Now, we do have provided for us the source code for server. If you go online to Microsoft MSDN, Microsoft Developer Network, you can find, believe it or not, some client source code. You are welcome to use it. You don't need to worry about plagiarism or modifying it or anything like that. That's what this particular exercise is designed to do. We're taking this and we're modifying it so that it just does this. If you want to write your own, feel free to do so, but certainly not expected. And I would save those energies maybe for other more time-intensive exploitation work. But if you want to practice your programming skills, feel free to do so. So that's really all we have, and all you need to do is to submit a screenshot that shows that you were able to achieve that. You don't need to go on and on explaining how it works. In this case, the screenshot will speak for itself, and additionally provide the source code for me. In terms of compiling it, we want to be using Visual Studio developer tools. So we can use the developer prompt, which I have right here. This is what it looks like. We can go and navigate to where our file is, and then we just simply type CL, command line, and then whatever it's called, C++, and then it'll compile it. When I get the IA Lab environment out to you, that will be in there. It will be provided. If you have your own Visual Studio, you feel free to use that. You don't have to do it on the command line. If you do it in the Visual Studio GUI, then that's perfectly acceptable. I like to do it in Sublime and use developer command prompt to compile. Other advantages and disadvantages to both, certainly. If you don't have it, there are free community editions. However, it can take a while to download, and so we'll see when those lab environments get put out to you. So I'll definitely take that into consideration. I'll put the assignment out there, but if you don't have a lab environment to work in and you don't want to download Visual Studio, that's fine. You can wait until the VM get set up, and I'll provide information once that has been done. So again, I'll take that into consideration when we establish the due date, which has not been set up yet, but it will be. So if you have the environment to start working now, then I encourage you to do so, and that's why I put this out there. But if not, then you'll get the chance later on. All right, cool. Talk to you later.